Hello students, today we begin our study of complex numbers. This is part 1 where we will learn about the definition, equality, algebraic operations and the concept of conjugate. Let us start from the basics. A complex number is written as z equals x plus iy. Here, x is the real part, y is the imaginary part, and I is the imaginary unit with the property I squared equals minus 1. Examples: if z equals 3 plus 2i, then real part equals 3 and imaginary part equals 2. If z equals 5, this is the same as 5 plus 0i, imaginary part is 0. If z equals minus 7i, then real part is 0 and imaginary part is minus 7.
Sir, may I ask a question? Are real numbers also complex numbers?
Yes, very good. All real numbers can be written in the form x plus iy with y equal to 0. So every real number is a complex number. Equality of complex numbers to complex numbers are equal if their real parts are equal and their imaginary parts are equal. Example: if z equals to plus 5, I equals a plus bi, then I equals 2 and b equals 5. Addition of complex numbers: when we add the real parts separately and the imaginary parts separately. Example: 3 plus 4i plus 5 minus 6i equals 3 plus 5 plus 4 minus 6i equals 8 minus 2i. Subtraction of complex numbers. In subtraction, again subtract real from real and imaginary from imaginary. Example: 7 plus 2i minus 3 plus 5i equals 7 minus 3 plus 2 minus 5i equals 4 minus 3i. Multiplication of complex numbers. For multiplication, expand like binomials and remember that I squared equals minus 1. Example: 2 plus 3i multiplied by 4 plus i. Step 1. Expand 2 into 4 plus 2 into I plus 3i into 4 plus 3i into I. Step 2. Simplify 8 plus 2i plus 12i plus 3i squared. Step 3. Since I squared equals minus 1, 3i squared equals minus 3. So result is equal to 8 minus 3 plus 14i is equal to 5 plus 14i. Division of complex numbers. For division, multiply numerator and denominator with the conjugate of the denominator. Example: 3 plus 2i divided by 1 minus i. Step 1. Multiply numerator and denominator with 1 plus i. So numerator is equal to 3 plus 2i, 1 plus i. Denominator is equal to 1 minus i, 1 plus i. Step 2. Expand numerator. 3 plus 3i plus 2i plus 2i squared is equal to 3 plus 5i minus 2 is equal to 1 plus 5i. Denominator is equal to 1 minus I squared is equal to 1 minus 1 is equal to 2. Final answer is equal to 1 plus 5i divided by 2.
Sir, why do we multiply with conjugate in division?
Good doubt. Multiplying with conjugate removes I from denominator, making it purely real. That makes division simpler. Conjugate of a complex number. If z equals x plus iy, then its conjugate is written as z bar equals x minus iy. Example 1. Z equals 3 plus 4i conjugate z bar equals 3 minus 4i. Now, z multiplied by z bar is equal to 3 plus 4i, 3 minus 4i is equal to 9 minus 16i squared. Since I squared is equal to minus 1, this becomes 9 plus 16 is equal to 25. That is the same as modulus of z squared. Example 2. Let z1 is equal to 2 plus 3i and z2 is equal to 4 minus I. z1 plus z2 is equal to 6 plus 2i. Now conjugate of this sum is equal to 6 minus 2i. On the other hand, Conjugate of z1 is equal to 2 minus 3i. Conjugate of z2 is equal to 4 plus i. Their sum is equal to 6 minus 2i. So overline of z1 plus z2 is equal to z bar 1 plus z bar 2. Property is verified.
Sir, does conjugate change the value of a number?
No. Conjugate only reflects the point across the x-axis in Argand plane, but modulus remains the same. Today we have completed part 1 of complex numbers. We covered definition, equality, addition, subtraction, multiplication, division, and conjugate with solved examples. In the next class, we will move to modulus, argument, polar and Euler forms, de Moivre's theorem, powers of I, and roots. Jai Hind.